Robin. Do you know any good jokes?
Yes. What do you call 2 banana skins?
I don't know. What do you call 2 banana skins?
A pair of slippers.
A pair of slippers. Very good. I was trying to think of a chemistry joke, but all the good ones are gone. Because argon is an element, isn't it?
Goodness me, the podcast hasn't even started yet, and my guests are already cracking gags. At least that last one is related to what we're going to be talking about in this episode. Which is what again, Mark?
Atoms. But the thing you've got to remember about atoms is you can't trust them because they make up everything.
I know that one.
You know that one. Good. Yeah, it's a good one, isn't it?
Guys. Let's crack on, shall we? Welcome to The Conversations, Curious Kids, the podcast where a kid asks a great question and we find a very clever expert to answer it. I'm Eloise and my 2 resident jokers are... Would you like to introduce yourselves?
Hi, I'm Robin.
And how old are you?
7.
And Mark?
Hello. My name is Professor Mark Lorch and I'm a biochemist at the University of Hull.
In the northeast of England.
But you can just call me Mark, okay?
So, Robin, what is your question for us today?
Will scientists be able to make a new element?
What a mind-boggling question. So, to start off, what exactly is an element? An element is any pure substance, like oxygen or gold. And most of them can be found somewhere on our planet. The best way to get to know them is by taking a closer look at one of Robin's favourite diagrams.
All the different elements, they're all arranged in a special table, aren't they? Do you know what that table's called?
Periodic table.
The periodic table, absolutely.
And I think I've heard that you have a book on the periodic table.
Yes, I've got it here.
Oh, brilliant.
Oh, fabulous.
The periodic table looks like a long rectangular but slightly misshapen waffle with rows and rows of colourful squares.
Do you know anything about how the elements are organised on the periodic table, Robin?
It's ordered into different groups of which one's the same.
That's exactly right, yes. So the elements that behave in the same way are all together. So down one side of the periodic table, on the right-hand side, you've got the noble gases. There's helium and then neon and argon and krypton. And those, they don't like to react very much with things. So they just sit there by themselves. So they're a bit like, I don't know, maybe you've got some people at school who like doing things by themselves and are happy playing by themselves. And then at the other side of the periodic table, you've got things like lithium and sodium and potassium. And those are all very, very reactive and have lots and lots of energy. And those you could be like your friends at school who are always whizzing around and talking to lots of other people and being very, very energetic. Yeah. And so all of the elements, in a way, they have their own personalities and they're organised in a way so that the elements with the similar personalities are together. A bit like sometimes your friends might join together if they've got similar personalities. And then the other thing about the periodic table is that the light elements are at the top and then the heavier elements are at the bottom. So again, it's almost like in an assembly, you might go in your classes, might you, in school? The smaller children might start first and then be followed by the larger children. So they're grouped together by what they're like and then also by how big they are. So that's what makes the periodic table.
So Robin, if you were an element, where would you put yourself on the periodic table?
In the transition metals. I wanted to be gold or silver.
Oh, that's a good choice because they're pretty.
And also because all of the precious metals are in transition metals.
That's right. The transition metals do all sorts of really super important jobs as well. So you've got things like iron, haven't you? And that makes steel and all sorts of other things. And mercury, like you get in thermometers and so on. So lots of really useful things going on in the transition metals. That was a really good choice.
If you peer closely at the periodic table, you'll also notice that each element has a number next to it. That refers to the tiniest particles they are made up of. Our friends from Mark's joke earlier, atoms!
This is where we're going to get our Lego out.
Have you got some Lego to hand, curious kids? If not, pause this episode and go and get some. So, elements are made of atoms. These are the tiniest pieces that make up everything around you, from water to oxygen to a tree. And at the centre of every atom is a nucleus. And inside this nucleus,
there's protons and there's neutrons. Have you heard of those before, Robin?
Yes.
Yes? So I've got 2 bits of Lego here. I've got a yellow piece of Lego and a red piece of Lego. So let's imagine that my yellow Lego brick is a proton. Yeah? And my red Lego brick is a neutron.
So we have a nucleus of 1 proton and 1 neutron. In element world, this is the gas hydrogen, the very first element on the periodic table. Helium is the second element, and it's got more protons and neutrons in its nucleus. Robin, can you maybe make helium for us with your Lego? What colours do you have with you?
Red and green.
Okay, perfect. So if your red ones are the protons and your green ones are the neutrons, can you make helium?
Yes.
Robin clicks the 2 red protons and the 2 green neutrons together to make
Helium.
helium. Super! Thank you so much, Robin. So you can just keep adding protons and neutrons to the nucleus to make new elements.
So hydrogen, number 1, has 1 proton, and helium has 2 protons, and lithium has 3 protons.
And beryllium has 4 protons, and boron has 5.
There's antimony, arsenic, aluminum, selenium, and hydrogen, and oxygen, and nitrogen, and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium.
This is a famous song by the American musician and mathematician Tom Lehrer. Now, back to the elements.
Thulium and thallium. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine
Right
and
up
terbium,
to
manganese and mercury,
The
and
last
magnesium,
one,
viscosity.
oganesson.
With 118 protons. This is Robin's favourite element.
Oganesson, oh really? Cool.
Remember I said earlier that most elements could be found in nature? Well, this element was made by scientists in a lab just a few years ago. So ta-da! It's true. Scientists can make a new element. But how do they do that? That's coming up after this short break.
If you're listening to this, you're either a curious kid or you've got one in the car with you right now. Either way, you're in the right place. I'm Marshall, co-host of Tumble, an award-winning science podcast for kids and families. We start with the questions that kids are actually asking, then take them to real scientists, covering everything from animals and dinosaurs to space and cats. Search for Tumble Science Podcast for Kids wherever you get your podcasts. Keep that curiosity going.
Hello, I'm Emma from the Earth Rangers podcast. If you think that animals are amazing, then our podcast is the one for you. Join me as I travel the world to discover the wildest animal facts out there and solve nature's biggest mysteries. If you're a fan of animal expeditions like on PBS's Wildcrats and the BBC's Planet Earth, or the mystery and intrigue of Carmen Sandiego, then you'll love the Earth Rangers podcast. This is a journey you won't want to miss. Follow the Earth Rangers podcast on Apple Podcasts, and for more information, go to gzmshows.com. See you soon!
Welcome back, curious kids. As we just found out, some elements are natural and some are made by scientists. These are known as synthetic elements. So how exactly do scientists make them? We might find a clue in the way the natural elements were made.
Hydrogen and helium and a bit of lithium, they were made in the Big Bang, right at the beginning of the universe. Did you know that?
Beryllium as well.
Oh, yeah, you're right, actually. A little bit of beryllium could have been made in the Big Bang. So where then do you think the rest of them were made?
I don't know.
Do you like to go outside at night and look up into the sky? What do you see up in the sky?
Stars.
Stars. And stars are element factories.
I know that.
Oh, you did know that. Oh, there we go. Many of the elements, are made in stars. Then some elements are made when stars explode. And then some elements, the really heavy ones, are made when certain stars actually collide and then blow up again. So you are made of stardust. Isn't that amazing to think almost every atom in you has been through a star?
Cool.
So as you can see, an enormous amount of energy is required to make elements. So how do scientists do that here on planet Earth? To understand this, we've got to take another look at our friends, the atoms. Because they're not just made up of a nucleus with protons and neutrons inside. They are surrounded by things called electrons.
You've got the nucleus right in the middle that's tiny and surrounded by a great big cloud of electrons whizzing around. And so actually most of it is just entirely empty, which is pretty amazing. And if you imagine that the nucleus that's made up of protons and neutrons is the size of a football, how big do you think the rest of the atom is? Do you know?
No.
It would be about the size of the rest of the football stadium. Okay, so actually the nucleus in the middle of the atom is tiny compared to the huge size of the atom overall. That's one of the reasons why making new atoms and making new elements is really, really difficult. Because to make a new element, you've got to get one element and you've got to get another element. You've got to fire the smaller element at the bigger element and hope that the nucleus stick together, like my chunky bit of Lego here in one hand, my helium in my other.
Mark holds up his helium nucleus, the red piece of Lego and the yellow piece of Lego stuck together, and another piece of Lego, and clicks them together.
Now I can do that here in my office, make the Lego stick together really well. But now imagine that instead of me just pushing them together like that, imagine that I'm standing in a next door stadium and I've got to fire my bit of Lego over the stadium and hit the bit of Lego that's sitting in the middle of the neighbouring stadium and hope that they stick together. And that's why it's so difficult to make an element.
But that doesn't put the scientists off. There are currently 118 elements, and right now, as we speak, scientists all over the world are trying to make element 119. Now, there are many different ways to do this, but my favourite way is wonderfully mathematically pleasing.
One of the ways they're trying to do this is by taking curium, which has a number 96, and taking vanadium 23 and firing them at each other and hoping the vanadium sticks to the curium.
And that's because 96 plus 23 is 119. So pow pow pow, there the machines go, firing atoms at each other to try and make this new element. But what if they do eventually stick together? Well, they're unlikely to stay together for very long. In other words, they are highly radioactive.
It's too big, it's too bulky, and it can't stick together properly, so it breaks up into little bits.
To give us an idea of just how difficult it is to make a new element, Mark explains what happened when scientists finally made the element 113, known as nihonium.
They had 4 trillion times they actually hit, but they didn't even stick together. And out of those 4 trillion collisions, how many atoms of element 113 do you think they made? Go on, have a guess.
1.
A little bit more than 1. They made 3 atoms from 4 trillion times that those bits of Lego, if you like, those nuclei hit each other. Just 3 of them stuck together. And then they hardly lasted any time at all. They decayed because they were radioactive, and they only lasted for 2 milliseconds. So 2,000th of a second. So it's really, really difficult to make new elements, and they don't last very long. And element 113 is a lot easier than making element 119 and 120.
Yeah. So Robin, imagine you're in your stadium and trying to throw your Lego into the next stadium. Do you think that they're going to be able to make element 119?
Maybe.
Maybe. Yeah, it sounds like maybe a matter of time. Just you need to keep doing it. Keep chucking your Lego into the next stadium until it locks onto another one.
That's right. Eventually they'll make some more elements and that'll start a new part of the periodic table.
So, why do you think that we would want to create new elements? What's the purpose of this?
That's a really good question. There's a couple of reasons why. One is that these new elements might have all sorts of interesting properties that might be useful. Have you heard of the element americium? That is element number 95. That's a synthetic element. And actually you find that in smoke detectors. And element californium, that's used in cancer therapies and so on. And nobody knew that these elements would be useful for those things when they were made. But it turns out that they were really useful. So if we make new elements, we might find that they're super useful for something that we haven't even thought of in the future.
That sounds good to me. Thank you so much, both of you, for joining me.
You're very welcome. It's a pleasure. Really nice to meet you, Robin.
Bye.
Thanks so much for listening to this episode of The Conversation's Curious Kids. If you've got a question for us, please do email us at curiouskids@theconversation.com and we will do our best to find an expert to answer it. This podcast was made by The Conversation, a news and analysis platform bringing research expertise to the world. You can go to theconversation.com and search for Curious Kids and find hundreds of answers to questions from kids just like you. The producer for this series is Katie Flood, and the executive producer is Gemma Ware. It was presented and sound designed by me, Eloise. If you like our show, go tell a friend all that you've learned about element 119, or even better, learn the element song by Tom Lehrer.
There's antimony, arsenic, aluminum, selenium, and hydrogen, and oxygen, and nitrogen, and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium.
There's even a version sung by Daniel Radcliffe, and we'll put a link to that in the show notes. See you next time.